Welcome to the CAD Office Training Series for FDOT Connect for Open Bridge Modeler 2023. My name is Sophie Von Kom and I'm a structural engineer with WSP USA. In this video, we will be covering exercise 5.6 from the Bridge Design 3D Modeling and Plans course guide. This exercise demonstrates creating a beam layout and modeling beams. Let's get started. I've opened up exercise 5.6 begin file, which shows where we left off in 5.5, which was modeling the deck, sidewalk, barriers, and added super elevation. OBM is designed to follow a top-down modeling approach where we create the deck based on the vertical alignment that's shown, and then creating beams that go underneath the deck based on a predefined beam layout in 2D plane, which hasn't been created yet. Before I get into this exercise, I'm going to run a quick demo showing you all the possible ways to maneuver through the beam layout definition window. To open up this window, make sure you are in the OBM workflow. In the Home tab, go to the Superstructure section and select Beam Layout. Select the start and end limit state respectively. I want to include both spans, so I'm going to select Support Line 1 and Support Line 3, also known as the front face of back wall of end bend 1 and front face of back wall of end bend 2. Left-click to accept and the Beam Layout window will open up. Down to the left shows a list of spans. Now let's say all our beams have the same parameters, so I'll make up 4 beams. To streamline this process, I can select the first span that I was editing as the default, then check this box to set all to default so that all my beams match. This way, I only have to input the parameters once, as the other spans don't allow editing. If all your bridges beams are slightly different, I wouldn't recommend this option because if I unselect Set All to Default, the rest of the beams have lost their inputs. But if I want specific beams to have the same beam layout definitions, I can select a specific span in the list to match the selected default span by right-clicking the default span, select Copy, and select which spans I want to have the same parameters. Now that I've gone through how to navigate the beam layout window, let's dive into the exercise. I first want to edit span 1 beams layout, so I'm going to click on Beam Layout tool in the Superstructure tab and select the front face of back wall and bend 1 and center line of pier 2, which is also the first and second support line of this bridge. Then left-click to accept and the Beam Layout window will open up. Some general information about what's in this window is at the top shows the alignment we selected based on the active bridge model. You can also add auxiliary alignments if the bridge is more complex, but we don't have any for this exercise. We can change the placement method to either simple or continuous. This bridge has more than one span, so we can select the simple span method. To start modifying the beam layout, I'm going to go change the number of beams to 5. These error pop-ups show because OBM doesn't like when the beams are placed directly on the edge of the deck. To fix this, I have to specify the edge distance for the exterior beams. If the left and right beam had equal edge distances, then I would input a value and hit apply, but for this example they have different spacing, so I'm manually changing the edge distances. Beam 1 is negative 37 feet and 3 inches, and beam 5 is 5 inches. Spacing reference can go off either the alignment, auxiliary alignment, left deck edge, right deck edge, or long chord spacing. For this bridge, we will be using the long chord spacing reference because the alignment is curved. For bridges with straight alignments, you can use the edge distance and spacing fields to lay out the beams. In 2023, Bentley introduced the short chord, which in OBM terms is called the alignment reference. This is a line that connects each support line rather than the entire beam layout selection, which is the long chord reference. Now that I have selected the spacing reference, I'm going to add in the spacing for the interior beams. Beam 2 is negative 27 feet and 10 inches. Beam 3 is negative 18 and 5 inches. And beam 4 is negative 9 feet. The reason the first 4 beams are negative is because they are to the left of the long chord, which is the imaginary line that starts at the intersection of the alignment and the start of the beam layout, and the intersection of the alignment and the end of the beam layout selection, which in this case is support line 1 and support line 2. Now I'm going to unselect the same beam start and value so I don't have to re-input the end spacings. If needed, you can rename the beams. Future versions of OBM no longer use the beam L and beam R naming convention. The 2 method options are along skew and normal. For straight bridges with no skew, choosing a method is less important, but for skewed and or curved bridges, using a long skew method may be easier to control geometry since it measures along the support line at the begin and end of the span. Next, we'll be changing the support line offset, which will move the beams a certain distance at the beginning and end of the beam from the support line. For this span, the support line offset at the beginning will move the beams forward 9 inches, and the support line offset at the end will move the beams backward 3 inches, which is why I'm inputting a -3. If the skewed end box is unchecked, that means the beam's ends are squared off, which is what we want our beams to be. Advanced bearing definition allows for more custom offsets, which we will not be adding. If the use chord box is unchecked, that means beams will be curved with a curved alignment. In our case, we want the beam straight, so we will check this box. Before placing the beam layout, I can hit Validate to check whether all my inputs don't run into any errors. This temporary preview shows the beam layout in the model. Everything looks good, so I'm going to hit Save. Now this will show the beam layout in our 2D and 3D model. Before adding the beams into our beam layout, I'm going to check that the parameters I inputted match with what's in the 2D model. To make it clearer to see, I'm turning off line work that we added in the previous exercise, so turning off the barrier and sidewalk level. Now I'm going to add the dialog box to draw the long chord reference, which is a line between the entire beam layout selection, which in our case is support line 1 and support line 2. Using the measuring tool, I'm going to measure the perpendicular distance between beam 1 and the long chord reference I just drew in. If it's correct, it should measure 37 feet and 3 inches, which it is. Now I'm going to measure the edge distance between the beginning of the beam to the front face of back wall, which should be 9 inches. And now I'm going to check the edge distance between the end of the beam to center line of pier 2, which should be 3 inches, which it is. If you want to go back into your beam layout definitions to view or edit anything, you can hover over the beam layout, click Properties, Pattern, and select to edit. Now we're going to repeat steps for span 2 beams. We're going to place beam layout, select support line 2 and support line 3, left click, add 5 beams. We're going to change the support line offset to 3 inches, which is flipped from span 1 beams. And then we're going to add different spacing from span 1. We're going to do 37 feet 7 inches, 28 feet 1 inch, 18 feet 7 inches, 9 feet 1 inch, and then 5 inches like last time. Then we're going to unselect the same beam start end values so we don't have to re-input the same values, and then we're going to do -9 inches for the end. Then we're going to change the spacing reference to long chord. And then we're going to hit Validate and check if everything's in there. It looks good, so we're going to hit Save. Finally, we have placed the beam layout so we can move on to the last step, which is modeling the beams. In the Home tab, go to the Superstructure section and select Place Beam. Select Beam Layout, make sure the feature definition says greater 1, and left click. On the left-hand side shows the beams we put in the layout, and in the Main section are the parameters where we define each characteristic of the beams. A few ways to navigate this beam definition window is you can select Apply to all beams, or if you want specific beams to have the same characteristics, you can select your default beam, right-click, Copy to, and select all the beams that you want to be the same, and then hit Copy by Ratio. For this example though, all the beams will be the same characteristics, so it will apply to all beams. Since the dataset is running in the 2023 version, the options for camber have changed. OBM now uses the curved camber to calculate the haunch for each beam rather than having to calculate the haunch by hand. So for this exercise, we will change the minimum clearance to 1/2 inch and camber to 2 inches. Make sure the beam type is custom. Change the start template by going to Standard Sections, F-dot, Fib 84. And lastly, change the material to pay item 04502, Fib 84. Now hit OK to place the beams in the 2D and 3D model. Repeat steps for span 2 beams. So again, we're going to select Place Beam. We're going to select the beam layout. We're going to change the name prefix to girder 2, and we're going to left click to open the window. And now we're going to change the haunch to computed, minimum clearance to 1/2 inch, the camber to 2 inches. Make sure the item type is custom. Change the start template, F. Fib 84. Change the material, pay item. Then select OK. And there we have it, span 1 and span 2 beams modeled. That is the end of exercise 5.6. We have finished placing the beam layout and modeling beam 1 and beam 2 for both spans for this bridge. In the next video, exercise 5.7, we will demonstrate how to model abutments. Thank you for watching this section of the training series for FDOT Connect. Additional training videos and course guides are available on the CAD Office Training webpage, which may be found at fdot.gov/CAD.